Okay, so this is my video for scientific notation. This is going to be kind of a shorter topic, pretty self-explanatory, which is, kind of funny considering this is a topic that took me, fucking forever to learn. So the fact that it's simple now is really awesome. But like, seriously, like it took me like 2 or 3 years to learn this. Anyway, so scientific notation, essentially what it does is it uses 10 to the power of something, whether that's like 10 to the power of, say, -3 or 10 to the power of 5. It uses that to move the decimal place. So this is really helpful when you're given like crazy big numbers and you need to round to sig figs, or even a number just with like a shit ton of zeros, which you kind of see here. Sorry, I have like the hiccups right now. So with using that number, you'll notice that this is similar to what we do for conversions among SI units. And that's because it does the same thing. The converting between SI units, say converting between milliliters to liters, it's not changing like the actual value of the unit. All it's doing is moving the decimal. Whereas like if you had something like converting from like, say, Celsius to Kelvin, that's a little different. And when it comes to units like that are not part of the typical SI units, this sort of thing won't work. Anyway, that's just a little tangent because that'll connect to another video. But for this one, we're going to solve some problems. Again, this is really simple, so it's going to go fast. So in this case, I have a little mouse here. Let's see. Oh, it's not scrolling. There we go. It doesn't seem to. Come on. Maybe I can just, yeah, there we go. We'll just do that. Okay, so for the first example problem, we get this crazy number. I'm not even going to read it out, and we want to convert it to scientific notation. We want it to have 2 sig figs. So how do we do this? Oh, let's see. Oh, crap. There we go. I just need, let me draw. We'll use red. Yeah, we'll use red, why not? Okay, so what you'll see is you see the decimals here, right? And in order to get 2 sig figs, remembering our sig fig rules, none of these zeros are significant. So, but the 1 and the 2 are. So with, another important thing, the number in front of scientific notation, it has to be less than 10. So for example, the number in front can be like 1.0 to like 9.9, but it can't be 10. So that doesn't work, but these numbers do. So the number in front, you want it to be essentially, you only want it to have a ones place. You don't want it to have like a tens or a hundreds place. Let me see. I want to write this better. We'll say, actually, no, we'll say exactly what we said. The number connected to 10 to the power of a number can only have the ones place. I'm going to add no tens place, no hundreds. And it's the dot, show that it keeps going. Yeah, so that gets the basic point across. So now that that's established, now we can go back to what we were doing. So we've got this number here. And these are the two units or the two numbers that we want, right? So we need to figure out how far do we need to move that decimal. So in this case, what you see is we need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So it'd be 10 to the power of 9, whether that's positive or negative, we will discuss that. And then we have, now that the decimal's moved here, that becomes 1.2 times 10 to the power of 9. So in this case, that 9 is actually negative. So when you make a, let me see here. How do I want to write this? So when you make a small number into a big number, the exponent is negative. And I have a little bit of an easier time remembering this currently because my first introduction to scientific notation was only positives and only making big numbers smaller, which is going to be our next point. So that's a little easier for me to remember. I'm sure some other people have other ways of remembering this. So vice versa, when you make a big number into a small number, is it going to let me? There we go. I make a big number into a small number, the exponent is positive. I'm just underlining it. So if you go over it briefly, just scan the page, then you'll know what's important about this. Okay, going back to what we were doing. So that's the logic behind why this is a negative, because we have this really small number. Then we make it into 1.2, which is a much bigger number. And now, just for the sake of it, how do you know that this works? Well, a good way to double check this is actually entering it into your calculator. So you'd go 1.2 times 10 to the power of negative 9. And you find that you get the exact same number with the same amount of zeros. And I did it on my calculator. So, if you want to do it yourself, then you can. And that's how it should work. That's also how you can double check that your scientific notation is correct, is by putting it in your calculator and making sure that you get the same number. Okay. Let it work. Come on. I have the touch screen off, so my arm doesn't do it. So I don't know why it's still causing me problems. Okay, next one. So you're given this crazy big number. So unlike the last one, this number actually has, I wonder why. I should be able to erase with my pen, but it won't let me. Sorry. Okay, so we have this crazy big number and we want it to 3 sig figs. So where would we move it? Do we want to move it the decimal that way? Do we want to move it this way? No, I mean, we just go back to what we said before. We can only have it to the ones place. So it has to move this way. We want the decimal to be here. So we would move the decimal 1, 2, 3, 4 places. So it's 10 to the power of 4 times, and here we have the 2.5. We want 3 sig figs. So we have 2.5, and this 0 here. Since it's a 6, we round that up, so it becomes a 1. So just like going back to what we said, why is it a positive 4? Well, that's because we're taking this big number and we're making it small. So that's why it's positive. Okay. And then the last one. Yeah. This number, it's not like crazy big or crazy small like the other one. This is just a more kind of normal number you'd see probably in like everyday life. And so this one's a little simpler. I mean, you have the decimal place here. You want it to be here. So just move it 1 over. And remember, since this is a big number, we're making it smaller, positive. We want 4 sig figs. So we have the 1.2, but then we also have the 3 and the 4. So 4 rounds up because of the 5, and it also becomes a 5. So that is the answer for that one. And then, let's see. Another point I want to make. Oh, actually, that might be in a different one. That is in a different one. Never mind. I don't have another point to make. Okay, so just to recap, scientific notation uses 10 to the power of a number to convert between either units. This goes more into conversion factors, converting, specifically with SI units, or 10 to the power of blank can be used to basically move the decimal of a number. So then you can have it either be easier to read, or so it fulfills certain requirements for how many sig figs you want your answer to be. And then just to recap, when you make a small number into a big number, the exponent is negative. When you make a big number into a small number, the exponent is positive. Okay, that's it for scientific notation.